How you doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world. And today, we're going to do some problems that we're going to be doing a review for tomorrow's test. And these are going to be proportionals, scale drawings, scale pictures, similar shapes, and scale factor, and a little bit of everything. Before we start, as usual, if you haven't, please subscribe, turn that notification bell on. And if you want to support the channel, check the links in the description below. Other than that, let's ride. So number one, it says, Stewie has a table that measures 21 inches by 15 inches. So this is Stewie's, right? And then Meg, she got another table for Christmas, and these are the measurements. Is it a scale copy? Yes or no? So we need to find if this thing is going to be proportional. And a while back, when we started talking about this, I showed you a quick and fast way to find proportionality. And this is what we're going to do. So all we got to do is take the two different proportions. So I like to label everything, as you guys know. So Stewie. So we're going to do Stewie's table over Meg's table. Okay? And then we're going to have the length and the width. Okay? If we label everything, then we should be okay. Usually, if it doesn't say length and width, I will take the bigger number to be the length, because that's going to make sense. And then if you're actually looking at the shape, well, this is clearly length and width. Okay? Questions so far? So now that I set up this proportion right here, I can just go ahead and fill in all the spaces right here. So for the Stewie's length, how long is that table? It's on green. The Stewie, green, length. What is that number? 21. And I'm going to put that right here. And then Stewie's width. What is the width for Stewie's table? 15. And you put it right here. And then we have Meg's. What is the length on Meg's? Length on Meg's. What is it? 16. So Meg length goes right here, and Meg width is 11. Now, what does that mean, mister? Well, in a perfect scenario, if I had something like this, for example, 1/4 equals 2/8. Well, I can see in here that if I multiply this by 2, I get this. And if I do the same thing to the bottom, I get this, right? So that's easy to see like that. But in this one, the scenario that we have, we don't have that. So the way we're going to solve this is by cross multiplying. So we're going to multiply these two. Let me do it in a different color. We're going to multiply these two. 21 times 11. 1 times 1 is 1, 1 times 2 is 2, and this is 11. Add it up, and you get what? This is 1, 3, 1. And we're going to write it right here, 1, 3, 1. Okay? And then we're going to multiply these two. 16 times 15. 5 times 6 is 30. Carry the 3. 5 times 1 is? Plus 3. 8. And then the bottom is 1 times 6 and 1 times 1. Add it up and you get 4. Carry the 1, that's 240. And we're going to put it right here. Now, once you multiply those two, this is what I want you to do. Compare them. Compare the two numbers. Are the numbers the same? Are these two numbers the same? Not same. Not same. So they're not proportional. Equals not proportional. So let's see. Answers, are they similar? First choice is yes, because both of them are rectangles. Remember, in order for them to be similar, two things have to happen. The corresponding sides have to be proportional, and the corresponding angles have to be congruent. What does congruent mean? Congruent equals the same. Well, the angles are the same because a rectangle has the same angles. So we're past that. But they're both rectangles, yes, but are they proportional? No. No, because 2 is stable is larger. It doesn't matter if it's larger as long as they're proportional. So that answer choice doesn't satisfy my reasoning. Then yes, because the angles are congruent. Well, the angles, yes, they're going to be congruent all the time on rectangles, but the shapes are not proportional. And we just found that in here. So it's not going to be that one. So it has to be D. And we did the work to prove it was D. Now let me show you something. For example, if I multiply these two, I know this right here, this set is proportional. What's 1 times 8? Put it right here. And 2 times 4? 8. Are the 8 and the 8 the same? Then those are proportional. That's an example that it is proportional just for you to compare. Any questions so far? Let's go ahead to number 2. And this one is one of those shapes that we have 2 triangles and we're going to have to work it backwards in order to find which one of those proportions is true. Okay? So, I don't know. I like to do the tick marks all the time. 1, 2, 3, and then do the same thing for the corresponding triangle. 1, 2, 3. We're not solving anything. Another thing that you can do is label them. Okay? How do you label them? With the letters J, H, K. So J, H, K. And I wrote it big, and I'm going to show you why. And if I started over here and I went like this, I'm going to do M, L, N. Okay? Now I'm going to compare, and I'm going to use my markers just to check on this. So 8 and 16. This is how we're going to do it. I'm going to identify the 8, which is right here. And then I'm going to identify the 16. I'm looking at A. This is the one I'm working with. 8 and 16. Are they on the same side? Both of them are on tick number 3. Good. Now, let's look at the other one. LM, which is going to be this one right here. Is that the same thing as 4? No? Yes. But now, look at the first proportion. 8. Where is it at? On the small one or the big one? On the small one. Let's label this S and B. So this is a S3 if I make a little label, right? So this is a big 3. So in order for this one to be proportional, this right here has to be on the small one and this one has to be on the big one. Is that what I have? Is LM the small one? Is LM, this right here, is that on the small one? No, so it cannot be A. Okay? Now we're going to do the same thing. Let me erase these markings right here and try the next one. 4 and 8. Let's see. I have 4 and 8. So both of them are on the small one. And then this is one tick mark. Small. So this bottom has to be both of them big ones. This is one tick mark, 3 tick marks, right? And then LM. That's on the big one. Is that on the big one? LM, yes. Is that one tick mark? Yes. What about 16? Is that on the big one? Yes. Is that 3 tick marks? So it seems like we have our winner. My answer is going to be B. Another way to see it is, for example, let me try C. 16 and LM. So 16 goes from here to here. Won't you agree? What 2 letters is that? That's LN. And then I'm looking at C right now. And this is, that's over this.
Good morning, teachers. At this time, we need Team Baylor, 8th grade Team Baylor down in the cafeteria. Thank you.
And then LM is right here. So then if I look, both of these are the big one. So both of these have to be the small one. So 4 goes from here to here, right? So that's HJ or JH. And I'm gonna put it on the same colors. Are the two or green circles on top of each other's? Are the two green circles on top of each other? No, so that's another way that you can do it. This one was a little more difficult to do it with the letters because we had numbers and segment names together. But if you do the tick marks, it'll work all the time. Work it backwards. Any questions on how to work this one out? Comments, concerns, issues, doubts? Anybody? Number 3. Says, on a rectangular parking lot, the dimensions are shown below. 192 feet by 72 feet. And then it says, the scale where 1 inch equals 24 feet used to create a drawing of the parking lot. What are the dimensions of the drawing? Okay, so again, whenever they give us the scale factor, I'm going to use that as my first proportion. And in this case, I have different units. So that's something that we need to take in consideration, okay? So I'm going to write my first proportion, and I'm going to have to find two different things. I'm going to have to find the length and the width, right? And if I look at the big one, well, of course, this is the length and the width. So whenever they're given the scale factor and you need to find two, whenever you're trying to find different lengths, we're going to have to do it twice. So again, my first proportion, this is my scale factor, 1/24. Okay? This is inches and these are feet. And then I'm going to find the length. And then I'm going to do the same thing. Inches, feet, 1/24. This is the scale factor, and I'm going to find the width. So, on the big rectangle, what number am I going to use for the first one, for this right here? The length, which is 192 what? Feet. The feet go on top or bottom, according to my setup? Bottom, 192. So that means this is X, okay? And then it's simple, cross multiply. Multiply this, multiply this. So this is going to be 24 times X is just 24X. And then 192 times 1 is just 192. And then all we gotta do is, I'm gonna rewrite it. I'm going to divide by 24, divide by 24. This goes away, and then you do TiVo here. 192 divided by 24. How many times those 24 go into 92? Well, let's see. 24 times 2 is 48. 48 times 2 is 96. So I'm going to call it 8 times. 24 times 8 is going to be 2, 3, and that's 16 plus 3 is 19. So this is 192. You subtract and you get 0. So what did I just find? X equals 8. So my length is going to be what? 8 what? 8 what? Where is it at? On top or bottom? 8 inches. Inches. So my new length is going to be 8 inches. Now I'm going to do the same thing, but now for the width. The width is given to me in feet. So if I set this up at the beginning, all I gotta do is put the fit right here and x right here. So again, this is 24, x equals to 72 times 1, which is 72. And then divide by 24, divide by 24. This goes away, and when you do TiVo, x gives you 3. And again, we're looking for inches. So this is 3 inches. Any questions so far? All right, guys, I think I'm going to call this a 2-part video because I don't want it to get too long. But so far, again, subscribe so you don't miss the next video. And if you haven't, please turn that notification bell on. And other than that, support the channel, links in the description. And let's ride.